Hi, my name is Benjamin Lannon, and today I wanted to go over a solution I made for being able to automatically deploy Discord bots up to AWS solely whenever I can make a new Git commit. So to start out, I have set up a bare bones Discord bot and have it pre-configured so it connects to a testing server. So prior to going through this, it's assumed that you have some sort of bot. You've gone to the developer portal on Discord and grabbed some tokens down so you can properly authenticate. So in here, we have a event. So whenever a message is created in one of my servers, I will make sure that the message is not sent by a bot. And if it's not, I'll send the message back saying you sent the contents of the message. So if I start up my bot and go over to a testing channel I have in my demo Discord server, I can say something like hello world, and my bot will respond. So we got the bot running locally properly. Now we want to go ahead and deploy it up to AWS. So start. And that's where AWS Elastic Beanstalk is going to come in handy. So this will allow you to spin up long-running processes such as a Node.js app on a EC2 VM without needing to worry about managing the VM itself. So we're going to go ahead and on the main page in the developer console for Elastic Beanstalk, we're going to create this create application button. And this is going to go ahead and we're going to start filling out. I'm going to call it AD bots for auto deploy bots, just to give it a name. We're going to scroll down. We're going to choose the platform we're using. So we're using Node.js, and we'll stick with the defaults that they provided. So it's going to be Node.js 16 running on a Amazon Linux 2 VM. Next, we want to go upload our code. So if I select this, it's going to ask for a label. This is for every deployment in Elastic Beanstalk. You give it just a new label to indicate this was a new deployment. But since this is the first one, let's just call it adbot source. And I want to go select a local file. So back in my code, if I open up my package.json, we have a zip script that will take all the files that we need to run this application and put them into a deploy.zip file, which we have here. So let me go ahead and go find that on my file system and upload it. All right, so now it was uploaded. So now we can continue on. So we're going to click, instead of the create application, we want to add a couple more configuration fields. So we're going to click on configure more options. And we're going to go through this. So we're going to scroll through. Let's start with the software fields. And I want to take a look at this instance log stream to CloudWatch logs and turn this on, because this will allow us to stream any logs that come from our Node.js bot or the server that's running on and set it up into CloudWatch for later viewing. As well, we want to go add a environment property, or what's better known as environment variable, to provide the Discord token that we use to authenticate. So we'll have Discord token, and I will be right back and put in the token that we need. Okay, so now we put in the token, and next we want to go into this capacity section. So in here, at the top, it's going to be set to be single instance, and this is what we want because we don't want to spin up more VMs given this is just a single node JS app that we're not really making scalable at the moment. We're going to use an on-demand VM instance. We're going to choose a ARM64 processor because it's a bit cheaper for running this. And then in here, we want to search for T4G Nano, which is the cheapest VM that's running on their ARM processors. So this equates to about $4 a month to run this VM, but the only cost at the end of the day is the VM itself. Where you keep the AMI, which is the image that is provided for us. This is the Amazon Linux 2 image, so we keep that. And then we'll click save. And finally, we want to go into this security tab, and we want to modify this IAM instance profile, because this is something we're going to be able to use where if we want to provide access to other AWS resources, we can give it a certain role, and then that VM will be able to authenticate and get access to any various items we provide it. So back in the code, I have a CDK stack that I used to deploy some various AWS resources that we need alongside this. And right here at the top of the constructor, I have this instance role and this instance profile fields that we generated, where this is going to be our custom instance profile that we want to use. So to start out, I'm providing the Elastic Beanstalk web tier as well as managed updates customer role policies. And these two policies are provided for Elastic Beanstalk to do its maintenance and general management of our apps. But then on top of that, if we wanted to add any other various permissions to allow this instance access to other AWS resources, we would just add it to this instance role. And anytime we push this up, those permissions would be added to the role. So I deployed this previously, and now if we go to IAM instance profile and we click this dropdown, we can see we have a couple of profiles. I have a profile for another bot I'm using that I'm doing this same workflow. But the one we are using is this AD instance profile. So we're going to click that. We're going to click save. And now our application is ready to go. So I'm going to click this create app, and I'm going to speed ahead because this takes a couple minutes to spin up the VM and properly provision all the resources that it needs to run our app. So I'll be right back. All right, and we're back. So now we can see that our bot was properly deployed up to Elastic Beanstalk. And if we go back to our Discord server, AWS, we can see that the bot is properly running. So now we want to next work on the configuration of anytime I make a commit and push up to GitHub, we want to deploy those new changes for said bot. Back in our code, I wrote a GitHub Actions workflow that will set up to use. So whenever we push to the main branch, we will go run some code, authenticate with AWS, and then push up our new changes. So to start out, we come through and we check out the repo. We use the configure AWS credentials, and we particularly use the role to assume field, which allows us to use OpenID Connect to say we want to assume a particular role, and rather than needing to have a long run token, we can have it give us a temporary token that will allow us to access those resources. So with this, back in the CDK stack, I'm using the AWS CDK GitHub OIDC construct that is a community provided library that allows us to grab a identity provider that I've previously set up in AWS, and we can grab the provider, and then we can create a new role using certain filters. So whenever a commit to landnumber/AD bot on GitHub is made, particularly on the main branch, it will allow us to get access to this role and use any permissions that we set up on top of it. So we add the two policies that were discussed for the instance role on top, and this will be all that would be needed for such. And next, we're going to go ahead and grab the node modules and zip up the files into that deploy.zip again. And then finally, we're going to use this Beanstalk deploy action that allows us to provide a zip and provide some various tokens, allows us to upload our new changes. And also we have this version label field, which is going to be that deployment label as was mentioned earlier in the video. And for this, I'm going to be putting in the GitHub SHA hash. So I know when a particular commit was made, I can see that commit SHA will be inside this identifier. So I can know that a particular commit is properly deployed. And if we go over to the GitHub Actions secrets page for this particular repo, I created 3 different secrets, which is the role that we were using to authenticate, the app name, and the environment name. So the app and environment name will be found in here. So the environment name is this main field of ad.env, and the application name is ad-bot. So I put those there. And now if we go back to our code, and let's go into our bot again and modify this to have the string AWS at the front of the response to make sure that we know we changed it and will automatically deploy. So let's save that. Update bot. We're going to add that as a commit. And we're going to push that. So if we go to actions, we can see that we have a workflow run that is going to be starting. And this is going to go ahead and authenticate. It's going to go add all those files. And down here, you can see that I am deploying this new instance. And now it is starting to update the environment. It is now deploying the new version of our code to the instance. And if we wait a couple more seconds, we can see now it's ready to go and the deployment was successful. So therefore, if we go back to, again, our Discord server for one last time, if I type test, we can see now I didn't go back into the AWS console and upload a new zip file. I just pushed a git commit and it now properly pushed up those changes using that GitHub Actions workflow. So that's going to be it for today. If you are interested in any of the things I discussed today, I am going to put various resources down in the description below. But otherwise, thanks for watching.